Good afternoon, guys. Thank you very much for being here. I appreciate it's fairly early on in the day, probably nursing a few hangovers here. We've got a lot to go through, so let's jump straight into it. So today we're going to be talking about some interesting ways of evading detection in Microsoft Azure, some of the methods we've picked up over the past couple of years. So just a high-level agenda of what we're going to be talking about, give you a brief intro, and then why do we care about this? What is the relevance of this topic, and why should we be interested? Then we'll look at some interesting topics around the current state of logging in Microsoft Entra, and maybe where there might be some gaps there. From there, we'll look at a specific service, the Azure ML service, and it has a bit of an interesting way of handling its identities. And then, what can we do about it? What can we take away from this? So, just to introduce ourselves, my name is Mehta. I'm actually with Secure alumni now. Yesterday was my last day, so this is secretly my leaving party. I'm now a founder of a company called Dolphin Labs, so check that out for any of my research and development over coming years. And it's my honor and privilege to introduce my colleague, mentor, and friend, Christian Philipov.
Thanks, Aled. So yeah, my name is Christian Philipov. My name is Christian Philipov. I'm a senior security consultant at WithSecure and heading up our kind of cloud capability area. So let's just get started, right, with the main question that I guess a lot of you have today, which is, why should you care about the topic of this talk? Well, it's because attackers do. Realistically, over the last years, there's been a massive move of organizations to use cloud services, and a lot of critical data has ended up moving there, and now attackers are focusing their efforts on that. Ultimately, your security perimeter has now changed for the most part, and you have a lot of cloud services that you need to be wary of. Like looking at Microsoft's Digital Defense Report in 2023, we can see a couple worrying stats that already kind of showcase that attackers are actively looking at cloud a lot more. Looking at this one, you've got the amount of potential data exfiltration events that Microsoft detected with their own suite of tools and Defender bits and bobs. Ultimately, not all of these will be legitimate data exfiltration events by a threat actor, but the fact that there is a significant increase practically linearly, you can definitely tell that attackers are recognizing that a lot of critical data gets stored in the cloud. Even more worryingly, looking at some of the stats on password brute force attacks, last year you had about a month or two where there were around 40 billion password brute force attacks detected against Microsoft accounts, which equates to approximately 4,000 password brute force attacks every second of that whole month, which is a lot. And realistically, the last worrying bit is that attackers are also getting more mature in their capabilities within the cloud. Like data exfiltration and password brute forcing, obviously very core kind of techniques that attackers use, but they're also getting more sophisticated. So as an example, a recent one with Midnight Blizzard's attack against Microsoft's own infrastructure, it's clear that attackers are recognizing a lot of the more advanced attack paths that take advantage of app registrations and enterprise applications/service principles to move laterally within these organizations. So it's really important that we focus on understanding what preventive controls we can do and detection controls, like detective controls as well. And as part of that, Microsoft are definitely doing a lot of really good things. Recently, they put in public preview the Microsoft Graph API activity logs, which will give you a lot more understanding of read events happening against the tenant. However, is that the full picture, and does that cover off all the possible enumeration activities and read events that an attacker can do to try to do some recon against your organization? Well, the answer is a bit nuanced, so I'll let Aled cover that off.
Nice one. Thank you very much, Chris. So just take a little step back first, talk about Microsoft Entra. So many of you should be familiar with this, but those who aren't, this is what used to be Azure Active Directory. So it's the core identity platform for Microsoft Cloud Services, whether that be Microsoft 365, Microsoft Azure, and a lot of organizations are using it as their core identity platform across all of their kind of business applications and services. So pretty easy to see that it's a high-value target for any attackers or adversaries. But what's the current state of logging in Microsoft Azure? In Microsoft Entra. As Chris alluded to a moment ago, we've got the new Microsoft Graph activity logs. So these are a great source of information for any kind of threat detection. Microsoft Graph is the core API for interacting with Microsoft Entra, and this will track any calls with that API. We'll go in more depth into that in a moment. We've got a couple of other log sources here. We're not going to focus on all of them. A couple I want to call out, though, are the sign-in logs and the audit logs. So historically, these have been kind of the core telemetry sources that we've used for threat detection and attack detection in Entra. So sign-in logs will, as the name suggests, track sign-ins for both users and service principals, both for interactive and non-interactive logins. The audit logs are quite interesting here. But crucially, they track state-changing actions in Microsoft Entra. So for getting read actions, we're relying on the new Microsoft Graph activity logs. So just get an idea of what kind of information we have available here. I'm not expecting you to remember all of this, but this is what gets surfaced through the Microsoft Graph activity logs. So we've got information about the principal that's making the call, what the request is, what the response is, whether that's successful, what body sent back, etc. So we've got some metadata there that's quite interesting. Let's have a little example of this in action, right? So for this, we're going to be calling the Microsoft Graph, and we've got the resource URI there of graph.microsoft.com. And crucially, we're going to be using a pre-registered client for this. I'll touch on the relevance of that in a moment, but we're going to use the Microsoft Azure PowerShell module for this. So grab a token from Microsoft Entra, and then we can make a call to Microsoft Graph. And here we're just using that token as an authorization header. And in this example, we're just listing conditional access policies. Cool, so we make that call and see what we get. Great, we can see we've got the ID of the policy, display name, and this is just a conditional access policy that's enforcing MFA for a specific group. Great, so what gets logged here? Cool, we can see we've got the request that was made, we've got the URI of that, and we can see it had a 200 response status. There would also be a response size as well there. But what is not logged? So there's a number of ways of interacting with Microsoft Entra, and one of the common ways was the Azure AD graph. So this is the legacy way of interacting with the service, but it's going to be around for a while. Microsoft have been deprecating it for quite some time, but there's still quite a few things that rely on it. So let's look at a similar example here. This time we're going to use a slightly different resource. You'll notice this is graph.windows.net, not graph.microsoft.com, and we're going to use a different client for this, the Azure Active Directory PowerShell module. And again, very similar, just get a token from Entra, and then we're making an API call to list the conditional access policies. Response of that, very similar. We notice the schema is a little bit different, but crucially, a lot of the information that we're getting here is exactly the same. We can see the ID, the name of the policy, and we can see that it's enforcing MFA for a specific group. But what gets logged? Well, nothing. If you recall from a couple of slides ago, we're talking about Microsoft Graph activity logs is purely for calls against the Microsoft Graph API, and the audit logs mostly capture state-changing actions. But for these enumeration activities, nothing is being logged there. What about another example? So there's the Ibiza IAM API. Bit of a strange name, but this is one of the APIs that is used by the web portal. So if you proxy the traffic or look at the network tab in DevTools, you'll see calls to this API. Again, this one doesn't have a pretty resource URI, so we're using the GUID for it instead. And we're going to use the same Microsoft Azure PowerShell module for the client as we did in the graph example. Slightly different requests here. We need to add in a couple of GUIDs for request and session ID just to help it be tracked. But very similar kind of action here. And you'll notice we're calling that main.iam.ad.ext.azure.com endpoint. Don't worry, I checked if there's an int.azure.com one. It isn't available. Get slightly different information listed back here, but we make one more subsequent call to get that specific policy definition. And again, we're getting very similar information retrieved, slightly different schema. But crucially, what gets logged? Well, nothing. It's exactly the same as we were seeing in the Azure Active Directory Graph example. We're not calling the Microsoft Graph API, and we're not making any state-changing actions. So it's not being logged anywhere. But what other APIs are there available here? So there's quite a few. I'm sure there's more that I'm not aware of. So we've got the Azure AD Graph that we touched on a moment ago, the Ibiza IAM API. We've also got a couple of interesting ones here, being the Provisioning API and the App Management API. So any of you who've been in the space for a while might be familiar with the old msol PowerShell commandlets for interacting with Microsoft services. So that was powered by this provisioning API. It's a SOAP API. We've also got this app management API, which the portal uses to get some information on enterprise apps, gallery apps, app registrations, etc. So you can see they've got a different amount of features that they support, but crucially, these all get logged in different ways. None of these are going to generate logs on the Microsoft Graph activity logs, and if you're doing enumeration activities, they shouldn't be captured in the audit logs either. So this should be a fairly straightforward way to avoid a lot of detection for, crucially, enumeration activities. And you'll notice I mentioned a couple of different clients here. So what's the point of this? So one of the key things is around kind of the OAuth consent flow in Entra. So for a client to be able to access a resource on behalf of a user, the user has to provide consent to that application, and that application has to be registered within the tenant. And for an adversary, this is going to be a challenge a lot of the time, because organizations should have their app registration and their consent quite restricted, so only set users can do so. This is where the first-party clients come in. So these are pre-consented clients available on any tenant, which have pre-consented scopes to certain resources. And these are used quite a lot with offensive and defensive tooling. For example, we've got AAD internals by Dr. Azure AD, we've got Road Tools by Dirk-Jan, and we've got Azure Hound by SpectreOps. So each of these take advantage of these different client registrations. And crucially, if you look at some of Microsoft's research, they're attributing usage of these to APTs like Nobelium as well. So we're really seeing organizations and attackers using these methods more and more. And what we're seeing a lot is a shift from necessarily targeting individual users, as Chris was showing in the first slide with the amount of brute forcing attempts we're having, to attacking service principals and workload identities, similar to what we saw in the recent Microsoft breach, where it was targeting an application registration. And I'm going to hand over to Chris to go in a bit more depth to a specific example of this with the Azure ML service.
Thank you, Alan. So yeah, let's talk about an interesting service in Azure called Azure Machine Learning. So what is it? Well, it's used for machine learning purposes. It's a nifty kind of one-stop shop for developers and engineers to work on machine learning models and integrate it with your organizational data to take advantage of kind of modern ways of trying to enable like advanced data enrichment and also make sure that you get like actionable and useful data out of it. So the important thing as well is that it natively integrates with Azure data services such as Azure SQL, Azure Storage, Blob, FileShare, and so on. So there's a nice way that you can get your organizational data to be used within that service. Now, the cool thing about it from a research perspective is that obviously that sort of integration with native services, ultimately having a separate studio that actually works and does a lot of the management plane stuff for it, and this native integration makes you kind of raise an eyebrow and think, oh, this is a very interesting way. I wonder, how does it actually provide users with access to this? Well, the short answer is it's two main ways that Azure Machine Learning provides access to the underlying data stores that are connected to it, which is credential-based access and identity-based access. Now, identity-based access operates in a way that people will be largely familiar with, especially the people that work with Azure, which is that it uses the Azure IAM backbone to effectively enable users to access services. So Azure ML doesn't do anything there. It effectively just pawns off like access attempts to Azure IAM to figure out whether or not the user has the respective roles to read data, write data, and do whatever with those underlying data stores, which is great. Then there's an interesting one, which is credential-based access, which operates slightly differently because you effectively delegate some of the access to Azure Machine Learning itself, and then it allows users of the workspace to access those data stores. So the intent here is that you can enable any user to directly access those data stores without actually providing them individual access, which I would assume a couple of you already are starting to think about like some ways that this could go wrong. And effectively, how does this service then actually permit users and what level of access does it provide them by default? Well, I think the easiest way is to showcase with a bit of a demo. So let's start that off. We're going to start off as a low privileged, if the demo wants to play. There we go. We will start off as a low-privileged user that has only reader capabilities within a subscription and only to 2 individual resources themselves. So one that we can see a key vault that is nicely named Central Team Vault. So it looks like it might have something interesting for us for later use or as part of like a privilege escalation activity. However, with the reader access that we currently have, we can see the resource, but we don't have any data plane read access, so we can't see any of the secrets. So let's see what we can do through Azure Machine Learning and see if that might help us do something. We can go to the Machine Learning Studio workspace, which is this is how it looks like, and we can just go directly to the Assets, Data, and Data Store section, and we can see all the integrated data stores within the service. Now, by default, it sets up a couple of blob storage and file shares, and we can see that somebody's integrated an Azure SQL database with it. So when we go into them, one interesting thing that you will notice is the browser preview on the right side. Like, when initially I saw this, I was thinking, oh, that's interesting. I wonder how does it actually enable you to access this service? Because typically, you'd need some sort of account key or a SaaS token to be able to do that, or be provided RBAC roles directly. So let's check the networking and see, we can see that a couple of calls are being made to /datastore/v.1.0, and that allows us to just filter it down just to make it easier to see the different requests. And one thing we'll quickly notice when we actually go through the requests is that we effectively ask the service, every time we try to go to one of those data store pages, we effectively ask the service, give me the credentials for that service that have been used to integrate it. And in the response, we can actually see the credentials in a second over there in the account key section. So we can immediately get full access to those storage accounts that have been integrated with credential-based access. Now, that's worrying in and of itself, but more interesting is SQL databases, because they can be integrated with a service principal. So we can actually get access to a service principal that would, at minimum, give us access to Azure SQL. But in some cases, due to sometimes poor practices being followed, you can have users use the same service principal for multiple purposes. So let's try and actually log in with that service principal and see how that looks like. So we can get the client ID from over there. We can get the client secret from the HTTP response. And then we can try to connect to the Azure AZ PowerShell module with a simple commandlet and passing the credentials to log in as that service principal, which worked out. So we've managed to log into that tenant as that service principal. And since we did see that one key vault that we have access to, let's see if that service principal might have access to that key vault. Because there could be legitimate reasons for an SQL database kind of service to access that, or respectively, as I said, there are often cases of bad practice that are being followed. And we can see that we actually do have the capability to interact with that key vault. We can see a nice, interesting secret being stored within it that previously we couldn't with our regular user just because we didn't have that data plane access. And we can just do a quick request to that specific secret and get the service principal credential out of it. So ultimately, one thing that I think we can, that I want to kind of share here is that credential-based access does ultimately present some issues, as we can kind of see, and can enable realistic privilege escalation activities within that. So it's very important that people follow the documentation and make sure that they use identity-based access, because that way, at least you can centrally audit who has what access to what data stores and what level of access they have to that. So that's on Azure ML. But let's summarize a bit the talk as a whole. Ultimately, I think the main messages me and Alet and I want to share with you is understanding your tools. Ultimately, cloud providers, Microsoft, and every other one, realistically, allow a lot of different services for a lot of different use cases. However, unfortunately, they have a lot of nuances on how they can be used and how access can be provided to users. So it's very important that you understand what those services can do and how they can be configured, and make sure that you properly investigate that to make sure that you're doing good security practices within your organization, as well as with the tooling that Aled mentioned, like with the Azure AD PowerShell module and the Microsoft Graph PowerShell like client. There are definitely ways you can restrict that to only administrative users by either requiring that those applications are assigned to those users to be able to actually log in, or even with conditional access policies targeting those clients respectively. And that would ultimately allow you to restrict the amount of people that can use those to interact with your tenant.
Yeah, and I think one of the other things that you can do based on the information when you understand what tools and what services are being used in the organization is building your logging and telemetry capabilities to match that. And it's important to understand that it's not one-stop shop with this. Like, there isn't one source that's going to fix everything. Things are improving, as we see with the Microsoft Graph activity logs, but we're still in the state where we don't have full visibility of what's going in here. So it's important to be using telemetry sources from a range of services, integrating them into a like aggregation and analysis platform, so you can get a holistic view on what is happening in your organization to be able to quickly and accurately detect all these threats.
And I think the last bit is like just continuously evaluating your current environment and your security controls. Ultimately, providers, like the cloud providers, move at a very fast pace. Stuff changes. As we can see, stuff improves. Limitations that exist in the past might disappear in a year or even less so. Ultimately, it's important that you actually, even if you do have certain risks that you've accepted and you've kind of said that, yeah, that's something we can't necessarily prevent or detect, then make sure that you evaluate it continuously with your engineers, with like your security specialists, to make sure that you are getting the right protection that you can get, and ultimately bring about a much more secure Azure environment for you and your organization. And with that,
thank you very much, guys. And I think we've got a few minutes for questions, if anyone has any.